All right, so let's say it starts initially at rest. We come up with let's get a number in there. So acceleration would therefore be 3 times, put it on Earth 2, 10 divided by 5 plus 3 plus 1. So that's 30 divided by 9. Is 3.3 meters per second. That's the linear acceleration of the 5 kilogram and 3 kilogram mass, and the tangential acceleration of a point that is on the edge here. So I have this wheel now, rotating about the center. I know the angular acceleration is going to be A over R, which was 3.3 repeating divided by 4 meters, which is 3/40. Let's see, that's 2.5. Yeah, because that's 3/10. No, that's 30/10. So 0.75 radians per second squared. Did it make yours there?
So is the general pattern to switch from linear to angular is just the radius? Because I think that's the pattern. Like if you change from displacement to angular displacement, isn't it like change in displacement equals a change in degree times r?
Yeah.
And then for velocity, it's velocity equals angular velocity times r. And then for angular acceleration, it's for a is equal to angular acceleration times r. Okay.
It's tangential acceleration.
Mm-hmm.
Sorry, just like math question. So you had 3.3 repeating over 4. Did you multiply both sides by 10, top and bottom?
Yeah,
I was gonna say, wouldn't it be 33.3 repeating over 40?
so that was, that was 30 over 9. So that would be 30 over 36, which is 5/6, like 8 repeating. Yeah, I don't know that. This is not the math you wanted. So I have the angular acceleration now, and I wanted to know where positive is into the board. And I want to know the angular velocity at some point on the wheel at some time.
Yeah.
Well, let's first figure out what the angular velocity is, and then we can find out linear velocity or whatever we need to. I know that if it starts at rest, my initial angular velocity is 0 radians per second. If I know acceleration, this is what I want to find. If I want to find what is the angular velocity what is the angular velocity of the wheel after 3 seconds? Well, I know that my final velocity equals my initial velocity plus acceleration times time. Zero plus 0.83 repeating times, I think I said 3 seconds. Radians per second. If I want to find the linear speed at a particular point, well, I'm using this relationship right here. And so if I want to find it at this point, r is, I think, 2 meters, then 4 meters. So 4 times that would give me, at that time, the linear speed at that point is 10 meters per second. If I were looking at the halfway, 5 meters per second. Looking at a quarter of the way, 2.5 meters per second. Looked like you were about to ask a question about it.
Oh, I was thinking of it, I'm like, I think that doesn't make a difference. Initially, I was thinking like, cause you're asking like, during what period, I guess, you said like 3 seconds is what you said. What about like from, I guess, 90 degrees to 0 degrees?
If you're doing that, so how fast is it going if it goes from, let's say, you have a point going from here to here?
Yeah.
Is that what you're saying? Well, we have to figure out how much time it took, or actually, we just need to know omega, that's ultimately what we want.
Oh.
So, I know that the change in the angle is equal to, let's see, initial angular velocity times time. Oh, no, that's not the one I want. I want omega f squared equals omega I squared plus 2 alpha dot delta theta. Just using the cake formula, just the rotational analogs. So that's 0. And this is 2 times 0.83. The change in the angle, well, it's going to go from here to here, so the change in the angle is into the board in the same direction. Pi over 2. Because I do want to be in radians. Do that, take the square root, I'll have my omega f, and plug that into that equation.
Wait, is that a 3D item or is it like is the circle that we're working with, is it 2D or 3D? Because why did we take into account k hat as well?
Because we're dealing with the rotational motion, the angular velocity, angular displacement, angular acceleration have a direction,
Yeah.
and that direction is into the board.
I thought it would just be like I had j hat for that one. Oh yeah,
Well, if I
because
have something rotating about the central point, it's easier to figure out the angular quantities and then use that equation to figure out the linear quantities.
if we use degrees and then we just use a conversion like 2 pi over 360, would we still get the same answer?
Should.
Okay.
Yeah, if you wanted to put 90 here instead of pi over 2, just be aware of the units you're working in. Because this is about 1.5 something versus 90, so you might be introducing a factor of 30 into your.
Isn't the acceleration supposed to be negative because we're going this way? Because if a unit circle is positive going this way,
I thought you defined positive k hat into the board. Somebody did.
you did?
I thought you did.
I did? I don't.
If you suddenly want to make k hat out of the board, then both of these would be negative. And you end up with the same answer. Or
I followed all of this, I can't remember where we got the 3.3 repeating from for A. Thank you.
plug and jug.
Okay.
That I gave you the masses and the mass of the pulley is 1/2 the mass. Before.
Don't worry, you're not.
Hope I didn't block something with my arm.
Yeah.
Other questions?
So when we're doing the weight, should it always be in the center of mass? So like when we're doing like a force diagram for this, because before I just put it anywhere, like could be on the bottom, could be on the top. But for
It really should be center of mass.
okay, and then can you explain how to find like the degree for the sign of a cross product? Because I keep getting confused. Because what I would usually do is just find the resultant, but is the wrong process.
Can I take a picture of that?
That, or the other one?
This, okay.
A cross B. So I'm multiplying two vectors here. The angle, you put them tail to tail,
Mhm.
that angle right there.
Yeah.
Okay, so you want something more,
Like, how do you find it? Like, what's the process? Because,
how are you given, what information are you starting with?
so I'm using the one from the ladder from that we
Okay.
did. So the moment arm has a 57-degree angle, and then I'm looking for weight acting down from
I'm
the
choosing
center.
that point as the pivot point?
Yeah.
Alright. So the moment arm is from the axis of rotation to where the force is applied.
Mm-hmm.
So it is that.
Yeah.
So I take my R, I take my weight, and that's the angle I want.
Mm-hmm.
I know that's a 90-degree angle. And this R is 57 degrees above the horizontal.
Yeah.
So that's 57 degrees. Well, if that's 90 and that's 57, then the whole thing must be the sum of the two.
So
147 degrees.
we have to always put the R and the force into a tail-to-tail method, and then look for some place that I can put like a supplementary angle in so that I can find a
I
relationship.
hesitate with the word always, but yes, that's
Okay.
a frequent thing we're doing.
Frequent enough.
Alternatively,
Oh no.
instead of a coordinate system,
Mm-hmm.
R is a vector, we'll just say 5 meters. It was 10-meter long ladder.
15 meter.
15. So this R, the length is 7.5 meters. So this is 7.5 meters, 57 degrees.
Yeah.
Little polar form right there.
Mm-hmm.
Put in rectangular form, that would be 7.5 cosine of 57 degrees I hat plus 7.5 sine of 57 degrees J hat. F is negative W J hat. So now if I'm doing a cross product, R cross F, well, I multiply that times that, and I get something I hat cross J hat. And then my weight times 7.5 cosine of 57 degrees. Plus that times that. Oh, wait, that's a negative there. Negative. And then I'd have a negative weight 7.5 sine of 57 degrees J hat cross J hat. That's 0. I hat cross J hat is K hat. So I'd end up with negative that K hat, which will get you the exact same answer as doing 7.5 times the weight times the sine of 147 degrees.
I'll stick with the first method.
Okay.
You lost me like when you said F equals negative WJ.
Yeah, how is F equals negative?
I said J hat is upwards. The
Okay.
force is this weight right here, which is acting downwards, so that's the negative J hat direction.
Okay.
My mind reading skills are not too honed to like understand what you're talking about sometimes, so I'm so sorry, that's my fault entirely.
Or your parent, you can blame your parents.
I should.
Why didn't you teach me mind reading skills better? I know.
Okay, it makes sense now.
Okay, other questions?
This is off of this topic, so it's okay to move on to something else. I have a question.
Yep, go for it.
Okay, this is more like, I guess, conceptual or whatever, and you explained it once, but I don't think I grasped it that first time. So in a perfectly elastic collision, right?
Right.
The third method that you do,
Yeah.
which is the lab frame, you shift. The shift that you use is the velocity from a perfect inelastic collision,
Yes.
right? Why? If it's too much, don't worry about it. 'Cause I get why. I get like the math and how it works. I'm
In
fine
a
with
zero
it.
momentum frame, you have two objects. So if you were in the zero momentum frame, those two objects would be coming right at you. They're gonna hit and bounce backwards. So I need to be in the zero momentum frame. Well, the zero momentum frame would be the center of mass frame. It would be the same thing. So as they are moving in the lab frame, there's a center of mass between the two, which is moving at its own velocity. And that in essence is what you're finding.
Oh, okay. And that's the same as perfectly inelastic?
Yes. Because when they collide together, they have to be moving at the,
Oh, okay.
the center of mass will continue. If we think about the law of inertia, object's gonna keep doing whatever it's doing. If we expand it slightly, the center of mass of a system is gonna keep doing whatever it's doing unless some outside force acts on it. And if it's a closed system, so I have only these two objects I'm worried about, that center, there's no external forces, so that center of mass will just keep doing whatever it's gonna do. So when they're stuck together, they have to be moving at that center of mass velocity.
Okay.
And then you cannot, when you're given a imperfect collision, you need, since that you can only use one equation because there's no conservation of kinetic energy, you can really only use conservation of momentum. You need the
You need some other piece of information.
Yeah, I think you told me about this, like you need to tell us the percentage of kinetic energy loss. How would you solve that?
Are you talking about for like an imperfect?
Yeah, I asked him about it, he told me like, it's either I give you the last one of the speeds at the final after the collision, or I give you a percentage of the kinetic energy loss, but I don't know where to plug that in.
All right, imperfect collision, the other piece of information I've told you is that it's gonna lose 10% of the kinetic energy. I have a conservation momentum that A V1 plus B V2 equals A V1 final plus B V2 final. Conservation momentum.
Yeah.
Technically, there are vectors in there, but it'll be plus or minus depending upon. The other one is, it's gonna lose 10% of the kinetic energy. In other words, it's gonna keep 90%.
Yeah.
So my final kinetic energy is gonna be 90% of my initial kinetic energy. So my final kinetic energy would be 1/2 mass 1 V1 final squared plus 1/2 mass 2 V2 final squared is equal to 0.9 times my initial. 1/2 M1 V1 squared plus 1/2 M2 V2 squared. So that's the equation set up. If I know I guess I switch from 1 to. So at this point, if I know my initial setup, the initial conditions, I know my mass 1. Wow, I am all over the place in my notation here. So I guess I said this was A. This is B. This is A. That is B. Okay. So if I know A and B, if I know the initial masses, I know the initial velocities, I will know all of that, I know all of that. And now I'm back to 2 equations doing those. There's no nice little shortcut. To actually solve this, you would solve for V1F or V2F, plug it in here, you'll end up with a quadratic formula. You are not going to get the initial conditions because you have to lose some energy.
Yeah.
So just a math problem at that point. Was it desire to actually go through the math, or just, let's talk about how to do it?
How to do it, but there was this, how about the simplified version of the kinetic energy? The conservation of kinetic energy was like V1F minus V, let me look at the equation.
Method two?
Yeah, method 2.
That's a separate topic. That assumes, one-dimensional, perfectly elastic collision.
The,
Those three methods all assume one-dimensional, perfectly elastic.
so I can't use the simplified version of the conservation of kinetic energy to solve imperfect. So I have to use a long method, okay.
Yes.
But could I simplify the equation if I move all the A's and B's together, and then I could cancel out, oh, no I can't.
Because over here, you'll have ultimately a V1 F squared minus 0.9 V2 F, or V1 squared, and it does not factor nicely.
Okay, what would be given to us? I know the initial speeds will be given to us,
I usually give initial velocities, initial masses.
initial velocities, initial masses, and then the final speeds will not be given to us.
Right. And here's a pro tip. If the question asks, what are the final velocities plural, I'm looking for two answers. If it says, what's the initial velocity, singular, I'm looking for one answer. Thank you for your guest appearance, Luis.
I wanted to ask if I could ask you if you could write on the condition.
No. Yeah. Yeah, yeah.
Thank you, bye.
Bye, you guys have fun.
You're in 152 in next week? All right, for those doing 152, you'll see Luis again.
Good luck.
I'll see you there.
Yeah.
Wait, did you say 152?
In the next term?
Yeah.
Yeah, in the B section.
No, I'm coming back in spring.
Some will. Based on